So, good evening, everyone. I hope you all guys are doing well. So, in today's session, we will be discussing some of the top data science interview questions. So, let's wait for a few seconds for people who are joining in. Meanwhile, if you haven't subscribed our channel yet, please make sure to subscribe it now and hit the bell icon to never miss an update from 360 Digit MG. So, guys, please stay tuned. We will be starting soon. We will wait 2 minutes for other people who are joining, and then we will continue. So, okay, let's start. Let's begin with the first question. So, the first question we have how deep learning differ from machine learning? So, how deep learning is different from machine learning? So, for few minutes, I will wait for your answers. Then we will discuss. So, the first question we have: how deep learning differs from machine learning? Please, guys, it's an interactive session, so I hope you will do the same. Please come up with your answer in the chat window. Please, guys, come with answers in the chat window. So, how deep learning is different from machine learning? So, for this question, first thing is you have to know that deep learning is not completely different from machine learning. To say that, okay, deep learning is a small part of machine learning, and the core machine learning based on the input. So, first, you have to do the feature extraction. You have to classify the features which are trying to explain your model better. These are some exploratory data analysis, and based on that, you will feed it to the algorithm, and those algorithms try to identify the patterns within those and give you the output. But in deep learning, it is a bit simplified that what happened in deep learning, it's totally based on the input the model, and the input the model will try to extract the feature on itself and will try to create on those. So it is trying to combine both the things of feature extraction and classification into a single thing, and give you the output, so that it is recently being very so that's why it is recently being very popular. So that is one thing. And the deep learning is basically, if you know, the deep learning is construct most of the neural networks. So neural networks are just basically a border from the idea of the human brains. And so how the human brain work and how the neuron within the brain really work in very complicated and effective manner. So those are the things which have been taken and being implemented the deep learning and machine learning. Machine learning is about the algorithm that basically pass and learn the data and tries to identify the pattern learned from the data to the new data, whichever is coming. So that is the most of the things which was related with the machine learning, but deep learning has come a bit more advanced to it. Is it okay? There is no answer on the screen. It's more theoretical thing, right? So I'm just trying to explain the things verbally for this question. Whenever needed, I will just type it or come with the answers. Is it okay? You are right, Chris. So as I already mentioned, deep learning is not completely different from machine learning. It's a part, right? Okay, let's move toward the next question. Oh, okay, we have the answer for this one. So it says deep learning is a form of machine learning that is inspired by the structure of human brain, as I mentioned, and it is particularly effective in the feature detection. On the other hand, machine learning is all about algorithms that are they learn from the data and then apply what they have learned to make informed decision. So this is the general definition. So the next question we have: what do you understand by selection bias? So as Prem Sai mentioned, it mostly deals with the unstructured data. Guys, I'm repeating these things. Please come up with the answers in the chat window. 15 participants are here, and a few people are just responding. So the next question we have: what do you understand by selection bias? No one? So let's understand first sampling. Yesterday, I think we discussed our sampling. So in statistical term, sampling is basically try to sample some data from your population. So you are trying to take some portion of the data from the population, and when you have some bias to some specific set of data. So I would like to take an example. So let's assume we want to take a population of all the data scientists within India. So when you are talking about India, you have to take the data from all parts of the India. But assume you just take sample from Hyderabad. So then you just take the sample from Hyderabad. You are getting a selection bias. You are getting bias to the Hyderabad, and you are selecting the data from that. So in this case, they are getting bias to those conclusions of your inaccurate conclusions of your, and you are not making the accurate decision based for the population. Okay, so that's the selection bias, and we can see the definition, general definition. So it's mentioned statistical error that cause a bias in the sampling portion of one experimental. The error cause one sampling group to be selected more often than the group includes in the experiments. And the third one is selection bias may produce an inaccurate conclusion if the selection bias is not identified. These all things we discuss, right? So that is the selection bias. I hope everyone is clear now. So let's see the next question. So the next question we have, what do you understand by precision and recall? So for the point of interview, this is very common question asked by the interviewer. So guys, please come up with the answers in the chat window. I wait for your answer and then we will discuss about this question. Anyone? So okay, let's see. Okay, low power mentioned recall is ERP or sensitivity. Okay. What about the others? Do you guys any idea what is precision and recall? Okay, let's take an example. I would like to take example. It will be more clear for you. So let's imagine that your parents keep on giving you birthday gifts from your first birthday. And one sudden day, they just come to you and asked you to remember all the birthday gifts from your parents. So you just get shocked, right? And in this case, you are trying to recall all the gifts that you had in your previous birthdays. And this recall that you are doing is nothing but the numbers of gifts you are actually correctly trying to recall it, and the actual gifts which have happened or event happened. So this is the ratio that you are trying to capture of all the recalls that you are doing correctly and the numbers of correct gifts which you got. So for example, if you are trying to recall out of 10, so suppose you are 10 years old, just for the simple, for understanding, better understanding. So the recall out of 10 are correctly, then your recall ratio is nothing but one of which is against 100, which is 100%. But if you are trying to recall only 7 gifts correctly, so as per the ratio, what will happen is the number of gifts you can correctly recall is 7, and the total number of gifts which are there is. So in this case, your ratio will be 0.7, which will be 70%. But let's assume you might be wrong in some cases. So for example, you answered 15 times, but out of this 15, the only 10 will be correct, and the 5 gifts you just answered were actually wrong. So you remember the terms of another event. So in this case, you recall all the gifts which are there, but it's not a complete precise. So for this case, the precision is the ratio that the number of events you recalling correctly, or the number of gifts you are recalling correctly to the number of events you recall. So which is like out of 15 gifts, you trying to recall 10 as a correctly, so that this is the precision which we have. So then, or really, the really gives 15 answers. So the ratio is 66%, which is 10 by 15. Okay, guys. So in a formula, you can represent all the things in a simple formula. So the number of gifts you can correctly recall are called as true positive. And so which you said as true, you are able to recall them correctly, and they are actually there. It's the number of all the correct gifts. So this is also again a true positive which you recall correctly, but the false negative which you did not recall. So the next thing is the number of gifts you recall to which is true positive plus false positive. So in this case, what is happening? The correct recall that you didn't all the gifts that you correctly remember, said okay, I recall them. So for an example, for example, when we had at 15, so in the case there was some like 10 and 5 false positive, which was you didn't recall them correctly. So based on all this obtained with this about the recall is true positive upon true positive plus false negative, which is our recall. So recall is nothing but the number of correct gifts, as we already saw. And so the number of gifts you can correctly recall divided by the number of correct gifts, and the precision is true positive divided by true positive plus false positive, which is the number of event you can correctly recall, and it's divided by the number of events or gifts you recalled. So that's about the precision and recall. Okay, let me show this thing. Recall is equal to your true positive divided by true positive plus false negative. On the other hand, precision is equal to true positive divided by true positive plus false positive. So the true positive is the number of events you can correctly recall, or the number of gifts you can correctly recall. It's not true positive from the example which we have taken, and the number of all events you recall is true positive, and they are correct, and it's mean you guess it correctly, and they are correct. So the number of all events you recall is the true positive plus false positive. The false positives, they are not correct, but you recall them right. And that's it for precious and recall. I hope you guys can understand this thing. Yes, it's the recall is true positive divided by true positive plus false negative. So this thing is clear, right? So let's see the next question. The next question we have explains false negative, false positive, true negative, and true positive with an example. So previously we saw the example of the birthday gifts. So for this question, you can also come up with an example. So where it will be more realistic, as it will give some more impact to it. So the next question we are explain the false negative, false positive, true negative, and true positive with an example. As Chris mentioned, true positive is when model correctly predict the positive class. Guys, please come up with the answers in the chat window. Guys, try to come up with a complete answer. So, okay, let's discuss. So let's take an example for this question, the true positive. So in this case, we can take some real example where what the model that we are trying to build, what it does on the fire. If suppose if there is fire, we will raise an alarm. Okay. So in the first case, it's true positive. So in true positive, what will happen if you said you have to do the alarm and there is actually a fire? So there is actually fire and you try to do it and you try to raise the alarm. So this condition is right. So that is the true positive. Okay, let me. So what is true positive? From the example, if alarm goes on in case of a fire. So fire is a positive and the prediction made by the system is true. So this thing is clear, right? Second is false positive. In this case, you raise an alarm, but there is no fire. So in this case, what will happen when you raise the alarm? There is no fire, but still people are running. So that is not good thing, and that is also called false positive. So false positive if alarm goes on and there is no fire. So system predict fire to be positive, which is wrong prediction. Hence the prediction is false. So the third one is true negative. So if you are not raising the alarm even when there is a fire, so this is the worst condition that we have in all the situations. So your aim is to raise an alarm when there is actual fire, but this condition says when you are there, there is still a fire. You are not raising any alarm. So this is the most harmful thing which can be there, and where your model is not working. So you have to very careful with this thing. And the true negative is something where there is no fire and you have not raised any alarm, which is still not good. So it's true negative if alarm does not go on and there was no fire. The fire is negative and this prediction was true. And then with the last we have false negative. It simply means if alarm does not go on, but there was a fire. So system predict fire to be negative, which was false since there was a fire. So I hope with this example, this question is very much clear to everyone. Okay, let's see the next question. What is confusion matrix? What do you mean by confusion matrix? So to explain this confusion matrix to your interviewer, you can just take a simple example. Guys, please come with the answers in chat window. The question we have, what is confusion matrix? I'm waiting for your answers, guys. Please come up with your answer in chat window. Okay, let's discuss. So I would like to take another example. So let's take a simple example, such as you want to create a model where what you are trying to look is you have a bank and the bank want to identify who are the customer we should be giving loan to, and so that they would default. Or so I have a training data where I know that looking at the data, these are the customers who were good at paying back the loan, and these are the customers to whom I gave loan but they are defaulted. So that the data is used in making this prediction, and you have a good model which has done this. So also assume that we have 165 people in the training set, and after doing the prediction, okay, so let's assume we have 165 people in the training set, and after doing the prediction, so in the training set, what we have, so we got actual 105 people can be given loan who didn't defaulted, and 60 people who the bank gave the loan but they are defaulted. So what your model is predicting? So in this case, it is says 110 people here can be given loan who will not default, and 55 people can be rejected. So as they are going to default, but this is on a higher level. But when you look at the confusion matrix, what happen is you will try to see, okay, how many models is performing and where are they true positive, true negative, and how should I take care or not take care. But how is it performing at the part of the false positive and false negative. So assume we have true positive. So in actual, there are 105 people who are the bank's training data. Say that we can say we can give them loan, and who didn't default, but out of the model identify 100 people, so which have a good thing. And for the number of cases, for the rejection cases, out of 60 people, the model said 50, which is again a good thing. But your model say for 10 people who are actually defaulters, but the model say you should give them a loan. So those are the things which can be looked into the future. But confusion matrix will help you to understand how your model is performing based on the predicted, the model output and the actual data which you have. So I think this thing is clear, right? So okay, let's see the next question. So the next question we have, what is the difference between inductive and deductive learning? Okay, let me answer. So basically a confusion matrix or uh, is a table which is used for, as you guys mentioned, summarizing the performance of a classification algorithm. So the next question we have, what is the difference between inductive and deductive learning? Guys, please come up with the answers in the chat window. So what you guys understand by the inductive and deductive learning? And based on this, what's the difference? Anyone? Let's try to understand the concept with the help of examples. Examples will help you to understand the concept. No one? Guys, am I audible? No one? Okay, low power, cost sensitive learning. Again, that penalize the wrong class predictions. So, okay, let's see. To explain you about inductive and deductive learning, I would like to take another example. So, so I can help you guys to understand this concept. So we can take some good examples, such as a father want to explain his son how the fire can burn him. So I think this statement is very clear, right? A father want to explain his son how the fire can burn him. So what can father do here? So there are two ways that he can teach his son as how he can get impacted from his the impacted from the fire. So first thing is the father, he will show him some examples, like he will show him some videos or he will show some demo as how the fire will get him burned. So based on the observation, the kid will learn and make some conclusion out of it. So that is the example for the inductive learning. So whether he will do the observation as see how the things are going to be and make some conclusion out of it at the end. For the deductive learning, it is like father is letting the kid play with the fire. So the father will wait till the father will wait till kid will get burned and try to make some conclusion out of it and have the observation after it, like it will get the kid will get himself by burn, and then he will say that okay, fire make us burn. So that is the deductive learning example. So in deductive learning, okay, let me so with inductive learning, what's happened first we will make some observation, and then after we go for the conclusion. So we observation first, and then we will go for conclusion. For deductive learning, first we make some conclusion and then you do the observation. So conclusion, then we will go for observation. This thing is clear. So is it making sense, right? So that example is very much clear for the inductive and deductive learning. So let's move towards the next question. So the next question we have, how KNN is different from K-mean clustering. Yesterday we discussed about KNN. Yesterday we discussed K-mean clustering, right? So here, what's the difference between K-mean clustering and KNN? Guys, please come up with the answer in chat window. Very good, Chris. You are right, love. KNN is supervised and K-mean is unsupervised learning. So the first thing you have to do is you have to understand the difference, as K-mean is unsupervised learning supervised technique algorithm, and KNN is supervised technique. So in KNN, we use as a supervisor algorithm, and use for classification generally, and also we can use for regression. And K-mean is used for clustering. As its clustering algorithm, it is used to create the cluster of your data. So K in KNN basically means it tried to observe the K neighbors. So in the case of regression, it will try to identify the surrounding K neighbors and take the average and give you the output. So in the case of classification, what it will do, it will try to see the surrounding neighbors, K neighbors, and whatever the majority of the classes, then it will assign the class for that. So in this case, K is your neighbor, K neighbor based. So in you on which, so in this case, K is your neighbor based on which on of regression and classification you can apply. We can do the classification as well as regression both. So in the case of K-mean, it is the K cluster that you are going to create out of your data. So K here, the case, both cases in different. For the both cases, K is different, and you have to give the difference of both to the interview. So one thing is, that okay, K-mean is unsupervised and KNN is supervised, so you can further go on the top of that. Is it clear? KNN is supervised technique used for classification or regression. On the other hand, k-mean is wise technique used for clustering. Is it clear? So, okay, let's see the next question. It's very important question. Can you explain me what is ROC curve and what it represents? The next question here, can you explain me what is ROC curve and what it represents? So in this question, interview is just interested to know how good you understand the ROC curve and how you can use it to understand to understand your model output. So basically, the interviewer is very much interested as how you are trying to use it. So he just you want to know how you can apply this for your model performance. Yes, law. It can be used as an accuracy measure for the classification problem. Yeah, it's used for to know the model performance, how better our model is performing. So ROC is also one of the performance parameter for our model, and this used in the case of binary classification, as Law mentioned. So what is the full form of ROC? So the full form for the ROC is receiver operating characteristic curve, and it is the fundamental. It's the fundamental you started with the diagnostic test for the evolution, right? So in this so it's used in the medical field. So one of the application is it's used in the medical field, and then after it started in machine learning field to just categorize the to classify related algorithm we can use. So in simplest term, it is a plot in true positive rate, which is also called as the sensitivity against the false positive. So what happens is once you get the output in the probability, you can use the different cutoffs, and you can just use the cutoff to distinguish between what is going to go for false cases, and you can plot the ROC curve. And ROC curve says when your curve is having so your curve is having say and one your model is good, and then you can plot it. If the ROC say, curve is one, the value is for it is one, then it means your model is good. and the plot with 50% is like 0.5, which is nothing. This is okay. Let me show you something. So here is the graph for ROC curve. So you can see the blue line, right? So if the plot within the 50% means 0.5, which is nothing, this line, blue line, you can see, right? So this is the worst case. It's like your model is saying you are a 50% chances in the prediction. It is just a normal guessing about the prediction. So the more closer to this and more area is this curve is trying to cover, the better is the model, the better is the algorithm for the model. So it's better if you are trying to predict the true positive rates than the false negative. So basically it's a trade-off there between the sensitivity and specificity, and the one will increase in the decrease in the other. So it is really important with the ROC curve, you will see this, right? See the difference in the curve, in the lines. As how would they are getting impacted, the closer of the curve follow to the true positive rate, true positive rate line, and the more area it's cover, such as yellow one, you can see, right? It discovering the highest area, that is more that is like more better our model is, and it's even showing the more better the pink one, it's better than the pink one, and the pink one is more better than the blue one. And the slope of the tangent line at the cutoff give you the likelihood ratio, as how likely your model is. So the first thing you have to remember, the area is much, the model is performing good. Okay, let's see the next question. So the next question we have, what is boosting and bagging in machine learning? So what do you guys understand by boosting and bagging in machine learning? Yesterday we discussed on the ensemble models, right? So both bagging and boosting is nothing, but it's the type of within the ensemble models. And we know that ensemble models are nothing but a collection of different models. They are also called as a weak learners. And we combine all these weak learners to get the output to create the single learner, which is better predictor of our model than the all weak learner. So both generate data from the sample. So you can take a random sample of your data. It is mostly within the replacement, right? As you take a data and you again then replace it, and you again take a different sample. So it's basically this process is known as we also call as the random sampling of your data. So in the both cases, all the weak learners are aggregated, as Lo mentioned. So they aggregated to create the final output. So in the case of classification, you trying to take the class which is coming over and the highest of the class. If you are training or like 100 models, and you have binary classification. So assume that output of 100 model is 80 models are taking that you are your class, and one should be there, and 20 models are predicting your class too. So so in the 20 models which they are predicting class 2 should be there, and on a sample class one would be selected as the output is in the case of regression. So in the case of regression we will try to average all the outputs, and there is a continuous data. Yeah, we are trying to aggregate all the outputs and from the different models. So both are good at reducing the variance, and are trying to learn different models they are. Yeah, guys, uh, we can use both. Both can help to solve the overfitting, but boosting also help us to reduce the bias, which is nothing just underfitting. Boosting help us to reduce the underfitting as well as, and both help us to solve the overfitting problem. So if I talk about the differences, so the boosting, what it does, so it's tried to learn different. It's tried to learn from different weak learner in a different sample. So the different samples are created, and each sample is trained on a similar model. So for example, if you are using decision tree, so on all samples we use decision tree, and each one predict their performance. So when we talk about the boosting, what it does, it is just simply try to learn from the previous mistakes that the previous model has performed. So each model is a better version of the previous model. So boosting try to weight the misclassified classes which were there in the previous model, and so as it keep on moving it's try to change their weight and create a new model, and show that the new model will give more weightage to the one we said misclassify in the previous model. So it keeps improving itself, right? So it keeps continues and try to improve the model itself. But in the bagging gives equal weightage to each model. I mean, equal weightage to the each model's output while creating the sample output for the output of your model. Is it clear, guys? Yes, Chris. Uh, both can help us to solve the overfitting, but boosting also help us to reduce the bias. Bias is like just which is nothing, just underfitting. Okay, so that was the last question we have for the today, and thank you, guys.